everybody, my name is Dr. Sam Monroe and I am an ecologist. That means I study plants and animals and how they interact with their environment. We talk a lot on this channel about how sharks and rays are in danger of extinction. Species all over the world are facing a deadly combination of threats, like overfishing and habitat destruction. But there is one species, a species most people have never even heard of, that is on the very brink of vanishing forever. Who is this unlucky species? Well, allow me to introduce the Maugean skate. This rare and unique species is so close to going extinct that unless we take rapid action, pretty soon you will only be able to find this species in textbooks or museums. That's why in today's video, we're going to learn as much as we can about this remarkable species, understand why it's in trouble, and explore what's being done to help. Let's jump right in. The Maugean skate is a type of ray, which means, just like sharks, its skeleton is made of cartilage, which is the same squishy substance that the end of your nose is made of. Males can reach a maximum length of approximately 70 centimeters, while females get a little bit bigger with a maximum length of around 85 centimeters. These skates can live for up to 10 years, and they like to eat small crustaceans like crabs and shrimp. Currently, the Maugean skate is only found in one place, Macquarie Harbour, which is a large harbour located on the west coast of the island of Tasmania. That's right, this one harbour on this one island is the only place in the world where we find this skate, which means it is one of the most geographically restricted species of shark or ray on Earth. It is also the only skate in the whole world that we know of that can live in brackish water. That is, water that is a mix of fresh water and seawater. Every other skate species that we know of can only survive in highly salty, purely marine water. Another mind-blowing fact about the Maugean skate is its incredibly long history. This species dates all the way back to the Cretaceous. It lived with the dinosaurs. This makes it one of the oldest skates on Earth. But sadly, that remarkable history could be coming to an abrupt end. As described in a 2023 report, scientists from the Institute of Marine and Antarctic Studies have found that the Maugean skate population has plummeted. In the report, they measure something called catch per unit effort, which basically measures how often or how many fish get caught each time someone goes fishing. What they found was the catch rate for the Maugean skate was low and getting lower over time, meaning it was getting harder and harder for them to find the Maugean skate. Based on these findings, scientists concluded that between 2014 and 2021, the Maugean skate population dropped by as much as 47%. That's nearly half the population gone in just 7 years. I sat down with Dr. David Moreno, an expert in Maugean skate ecology, to ask him just how small the population might be and where it's headed.
I am David Moreno, and I am a research fellow at the Institute for Marine and Antarctic Studies in Tasmania. For the last 10 years, I've been lucky enough to work on the sharks and rays of Tasmania, including the Maugean skate. We don't have a good estimate of what the current number is. Our best estimate is that there may be around 1,000 individuals left in the wild. But what we do know is that the general trajectory of the population has shown a significant decline in recent years. But there's other concerning signs in that the population as it exists right now is not very healthy. The individuals that we're catching are getting older, and we're having fewer and fewer juveniles come in. So that suggests that something is happening that is preventing new skate from coming into the population. We're thinking they're not actually being born into the population, so something might be affecting those young animals.
So, in a nutshell, Dr. Moreno and his colleagues have discovered that not only is the Maugean skate population getting smaller, it's also aging. Far fewer baby skates are hatching and surviving until adulthood. This means there won't be enough new young skates to replace the old ones when they die, which ultimately means the species won't survive. But why now, after surviving for millions of years, is this species suddenly in a tailspin? You might assume it has something to do with overfishing, since overfishing is a major cause of shark and ray population decline all over the world. But in this case, while fishing is a potential contributing factor, it is not the main problem. The biggest issue for the Maugean skate, the reason scientists think its population is declining, is actually poor water quality. The water in Macquarie Harbour doesn't have enough dissolved oxygen, which means, for lack of a better word, the Maugean skate is essentially suffocating. Just like humans, skates breathe in oxygen, except they extract oxygen from the water using their gills, while we extract oxygen from the air using our lungs. But if there isn't enough oxygen in the water for fish to breathe, this can negatively affect pretty much everything about their lives. This can include reduced growth or lower reproductive rates, and in extreme situations without enough oxygen, fish just drown. So we can see why not having enough oxygen would be such a serious problem. But that leads us to our next question, which is, why isn't there enough oxygen in Macquarie Harbour? Well, it's important to understand that there isn't just one cause for this problem. It's actually a really complex situation. So we are going to break this down step by step. It starts with the fact that Macquarie Harbour is just naturally very low in oxygen. Macquarie Harbour is quite large. It's about 6 times the size of Sydney Harbour, with a maximum depth of about 50 meters. And it has a very narrow and shallow entrance to the ocean. It also naturally gets a lot of freshwater flow from 2 large rivers that drain into the harbor. Because of its shape, narrow entrance, and all of that fresh water flowing into the harbor, the water in Macquarie Harbour is highly stratified. This means the harbor is made up of distinct layers of water, each with different amounts of oxygen and salt. At the surface, there is a thick layer of fairly fresh water that flows in from the rivers, and this layer, relatively speaking, usually has high concentrations of oxygen. There are also deeper layers of salt water at the bottom of the harbor that are naturally much lower in oxygen. Because salt water is heavier than fresh water, the salt water sinks to the bottom and the fresh water tends to stay on top. And these different layers don't really mix. The shallow freshwater surface layers tend to have a lot more oxygen because the freshwater from the rivers brings oxygen in, and the wind and waves at the surface churn things up and mix oxygen into that surface layer. The deeper water layers are naturally low in oxygen because they don't get any of this fresh water or wind action. The deeper water also has naturally lower levels of oxygen because dead animals and plants sink to the bottom of the harbor and decompose. The process of decomposition uses up a lot of oxygen and can produce a lot of carbon dioxide. The water near the bottom of the harbor also tends to just sort of sit there for a really long time. And the longer the water just sort of sits at the bottom with dead stuff decomposing in it, the less oxygen it's going to have. Sometimes large amounts of oxygen-rich salt water will enter the harbor through the narrow entrance. This can bring a new supply of oxygen to the bottom of the harbor, but this doesn't happen very often.
The main thing is that it's only connected to the ocean by this very, very narrow and shallow channel. And there's 2 major rivers, the King and the Gordon, that have a delta in Macquarie Harbour. So there's a lot of fresh water and very little exchange with the outside. And on the inside, it's basically a bathtub. Because of the differences in the density of the fresh water and the salt water, there's very little mixing. So new oxygen very rarely comes in. You have basically 3 different habitats, 3 different worlds that exist one on top of the other. On top of all that, the fresh water, because of all that forest, it's very rich with humic substances. So all this organic material from the plant matter, which make the water roughly the color of a very strong tea, which means that there's very little light going into the water. So even though it's a shallow coastal estuary, there is no light. So it's diving in Macquarie Harbour, it's like diving in the deep ocean. And what that means is that there's very little plant matter. There's no algae, there's no photosynthesis going on. So you get this weird coastal estuary, which doesn't have a lot of life in it and doesn't have a lot of oxygen in it. So it's a very challenging environment. So it really has, throughout millennia, really bred this unique community of animals that are very rough and rugged because they had to evolve to live in what's a very challenging environment.
Now, it's important to understand that under normal conditions, these naturally low levels of oxygen wouldn't be a problem. As Dr. Moreno has pointed out, the Maugean skate, as well as all the other creatures living in Macquarie Harbour, have evolved to deal with these unique conditions. But if the Maugean skate has evolved to survive in habitats with low oxygen levels, why do scientists think that low oxygen is causing their decline? Well, the trouble is, human activities in the harbor and on land have reduced the already naturally very low levels of oxygen in the harbor. The oxygen levels are now much lower than what they would be naturally, and this is what's causing the problem for the Maugean skate. Humans affect the amount of oxygen in Macquarie Harbour in 2 ways. First, we can reduce the amount of oxygen entering the harbor, and second, we use up what little natural oxygen is there in the first place. For example, humans have reduced the amount of oxygen entering the harbor by damming the major rivers that feed the harbor, and this can impact water circulation and oxygen distribution. But we have also used up more oxygen by adding organic material and waste into the harbor. Extra organic material leads to more decomposition, which, as we already discussed, uses up oxygen and produces CO2. Some of this organic material and pollution flows into the harbor from the rivers. Local industries like mining and forestry have historically discharged a lot of pollution and organic waste into the rivers, which ultimately makes its way to the harbor. Another source of organic material comes from salmon farms. Salmon are raised for food in large pens inside the harbor. Putting extra fish in the harbor means there's more fish using up the oxygen. But the waste that gets produced by salmon farms, such as salmon food or feces, is also a problem. This waste falls to the bottom of the harbor, where it eventually decomposes, using up oxygen in the process.
Since European colonization, really, human activities have significantly changed the harbor. We have changed the harbor by increasing the contamination from heavy metals that has come down the rivers when the rivers were being used for mining. The harbor was very severely changed when the external wall was built on the entrance to the harbor. The dynamics were also very heavily changed when the Gordon River was dammed and the natural river flows were altered. And more recently, in the last 20 years or so, there has been the development of a salmon aquaculture industry, which of course puts new fish into the system, which affects the rate at which oxygen is being used. So all of this is on top of those natural dynamics, and it's affecting how oxygen is being used in the system, but also how new oxygen comes in. And it's that very complex combination of factors that is resulting in the recent declines in deep water oxygen that we've seen in Macquarie Harbour.
The climate crisis is also a compounding factor. The temperature in the deeper water of the harbor has increased by roughly 2 degrees Celsius over the last 30 years. This is bad for two reasons. One, warmer water could be stressful for the skate, and two, warmer water can't hold as much oxygen, making the problem even worse.
You can think about the oxygen in Macquarie Harbour as a bank account, and basically for the last few years, the expenditures have been higher than the income of oxygen. So we're running the system into the red. We're not done a very good job at balancing the checkbook. And that's why we've seen the decline in oxygen levels.
In these difficult conditions, the Maugean Skate can use all sorts of tricks to try and cope with the low oxygen levels. For example, Maugean Skates might slow down their metabolism so they're using up less energy, or they might spend more time at the surface where there's more oxygen. But these strategies come at a cost, and the skates can't spend all of their time in shallow water.
When they experience low dissolved oxygen in their preferred habitats, they will shift the way their internal physiology works so they can depress their metabolism using less energy and therefore using less oxygen. Now, of course, this is an incredible adaptation, but it is also not a sustainable long-term adaptation, because if you're taking energy away, it has to come from somewhere. So it comes at the cost of things like growth and reproduction. The other thing that they do is that they can alter their behaviors somehow. So what we've seen is that the skate prefer to live in a depth of from 7.5 to 12 meters, roughly. When conditions are not favorable in those places, what they'll do is that they'll start moving up to the shallows where there's higher oxygen. That unfortunately comes with its own set of problems. Going up into the shallows obviously exposes them to a wider range of temperature. But also, one of the things that we discovered was that even though this is the only skate that lives exclusively in brackish water, we always sort of assumed that they were very good at dealing with fresh water. And what we found out was that they can tolerate it okay, but it comes with a very high energetic cost. So what that means is that, unfortunately, if that exposure to low oxygen goes on for too long, their mechanisms to cope with low oxygen for a short time start fighting each other, because they'll depress their metabolism on one end, but they'll also increase their activity and go to places that have a higher energetic cost in trying to get away from it.
These low oxygen problems are exacerbated by extreme weather events. For example, in 2019, a strong storm hit the harbor. This resulted in something known as an inversion. During the storm, a lot of salt water was forced into the harbor from the ocean all at once. This caused all of the oxygen-depleted water at the bottom of the harbor to get pushed to the surface. In other words, the water column got completely turned upside down. The result of this inversion was that no matter where the skates were in the harbor, they were exposed to very low levels of oxygen. The irony of this is The salt water that came in from the ocean is generally a good thing because it's full of oxygen and can help replenish the oxygen at the bottom of the harbor. The problem is, this event just happened way too fast for the skates to be able to cope.
And the reality is that that seawater that came in was very high in oxygen. So probably in the long term, it was a good thing because it recharged the harbor, but it's just the suddenness of this inversion event.
Because that's sort of the interesting dynamic with this harbor is we need water coming in from the outside, from the ocean, to replenish the oxygen supplies in the deep water environments. But because of the way it happened in that storm, such a large amount, so forcefully pushing low oxygen water up, it meant that the skates didn't have time to deal with the sudden change in conditions, and there was nowhere to hide. So long term, we want more events where there's salt water coming in from the ocean, but we just don't want it to be giant storms.
And that's one of the that's one of the difficult things about talking into the future about how to manage this species, because like you say, we want to do things that will encourage new oxygen from coming in, but we don't want to do it too quickly or too violently.
Do you know how many skates died directly as a result of that 2019 storm?
We actually had animals that had electronic trackers as this event happened. That's the only reason actually we know what happened. Of the animals that we were tagging, about half of them died as a result of that. And the fishing data suggests that big decline of about 50% also happens sometime around that time. So it's not a stretch to think that that a significant proportion of the population, potentially as high as 50%, although likely a little bit less, was lost in that event.
It's important to know that low oxygen is not the only problem that the skates are facing. Additional potential threats to the skate population include things like habitat degradation, fishing, inbreeding due to their small population, and introduced species, which could be competing with the Maugean skate for food and potentially eating its eggs. However, the full impact of these other possible threats has not been directly studied, so we don't really have a good understanding of how it's affecting the population right now. We need a lot more research to understand the combined interactions of all of these different potential threats. Putting this all together, it becomes pretty obvious that the Maugean skate is in a dire situation. Some scientists believe that this species could be extinct within a decade. If another extreme storm were to hit the harbor, this could push the species beyond the point of no return. But despite the numerous and complex challenges this species is facing, there is still reason to hold on to hope. Scientists, stakeholders, and the local community are all investing in improving the harbor and saving the skate. For example, as of November 2023, scientists are working to establish a captive breeding program for the Maugean skate. This will help safeguard the species while simultaneously improvements are made to the oxygen levels in the harbor. Engineering solutions are also being explored, where people are looking at ways to add oxygen directly back into the harbor. But as Dr. Moreno explains, this isn't going to be an easy fix. There isn't just one reason that the Maugean skate is in trouble, so there isn't going to be just one solution.
The good news is that we are pretty hopeful that action is happening on time. The situation is pretty dire, but we think there is enough time to intervene now. And the reality is that for a change of the magnitude that needs to happen in the time that we need it to happen, it's not a single strategy. There is no silver bullet here. So it's about trying to pull from different areas and trying to bring all the stakeholders together and really make sure that everything is being looked at the same time. And it's this combination of factors that is being used to try to solve the problem.
So while the Maugean skate is definitely in trouble, it's comforting to know that there are so many people from so many different backgrounds working together to protect this species. Now, some of you might be wondering, why are we putting so much effort into a species that's only found in one part of the world and it's just a little fish? Who cares? Well, Dr. Moreno has an answer for that.
What would you say to someone that says, oh, this skate only is found in this small area, it's just one place, it's just one little animal, why should I care?
I mean, it is a good question to ask because it is a lot of effort that goes into saving these animals. And I would answer that there's many reasons why you should care, and we should be doing this. First of all, again, the whole ecosystem is quite unique, and this animal is a pretty unique part of that ecosystem, an intrinsic part of having that ecosystem healthy. We are in Australia. We are Australians. Take out of pride in our natural fauna and the uniqueness of our animals, and so I think the cultural loss of completely losing one of our animals that exists nowhere else forever, it would be too much. Some of our animals, including the Maugean skate, have cultural significance for Aboriginal communities. And finally, are we willing to accept that an animal could disappear forever under our watch? And the lessons that we learn are not just lost here, right? The investment that goes into trying to save this species, the lessons that we learn, the techniques that we develop, that would hopefully help us make sure that it doesn't happen in other species. So it's not a sunken investment. It's really an investment in the future of conservation in general. And as crazy as this is going to sound, this would be the first example ever in modern times of a shark or ray species going extinct. And I really do think this is a bit of a litmus test, a canary in the coal mine. And it really is just a test of, do we have, as a group of monkeys that live in this planet, the ability to look at a complex problem like this and decide that we're going to stop something like this from happening and actually address it and deal with it?
I can't see into the future, but I have faith that this group of monkeys can and will find a way to protect this species. And don't worry, I promise I will keep you up to date on any news about the Maugean skate, good or bad. All right, everybody, that's gonna be it for me this time. Thank you so much for watching. If you wanna learn more about the Maugean skate, I have included all of the links and references that I used to create this video in the description, so go ahead and check those out. You can also help the Maugean skate by liking and sharing this video to spread awareness about this amazing species. I have a growing collection of other videos on ecology, including a few fun reaction videos to shark movies, so if you're keen, go ahead and check those out now. As I said, thank you so much for watching. I really appreciate it, and I'll see you next time.